Good afternoon, class. Today we are going to talk about our last section in Chapter 8, and it deals with variance and standard deviation. So these are two items that you should have seen before. Now we're going to be looking at our data sets and then now analyzing those data points, what we can find from each individual data point and what that actually means overall with our data. So we have all these data points, and we can look at each one and determine, okay, based on the mean, we can find some information. Based on the median, we can find some information. Two things we've looked at already is range and the interquartile range. But again, those only use two sets of data points. So now maybe we want to look at a few more. So the first idea we're going to talk about is variance. And variance combines all the values in our data set to produce a measure of the spread, how much the data is spread out. Now it's the arithmetic mean of those squared differences, the difference from the mean and each value. And I'll tell you in a minute, we'll talk about why we're squaring those differences. So squaring the differences between each value of the mean and the mean value has at least three advantages, because squaring makes each term positive, so it's a value above the mean. Values above the mean do not cancel the values below the mean. So for example, if our mean was 5 and we have data points of 6 and 4, then they are 1 and -1 units away. And when we take the sum, these would cancel out, and we don't want that. Also, squaring adds more weighting to the larger differences. So this can be significant when interpreting points further away from the mean. If we're looking at any sort of an outlier, those have a strong impact on our data set when we're looking at this variance, and squaring them just adds more weight to that. And mathematically, it's relatively manageable when using this measure in subsequent statistical calculations. So mathematically, it's most often that we will use variance. When we're not using variance, the one we're going to look at is standard deviation. And standard deviation is just going to be the square root of our variance, because remember, with our variance we were squaring our values, and so that's changing the units. So if we were working, say, in kilograms, well, our final unit of variance would be kilograms squared. Well, if we're just trying to find that difference in kilograms, if we're trying to find that spread, well, standard deviation, we take the square root of our variance, brings us back into kilograms. So we're looking at the difference in kilograms rather than units of kilograms squared. So both are measures of spread and have their own applications, but we'll focus more on the standard deviation piece. Okay, standard deviation shows how much variation there is from the mean and gives an idea of the shape of that distribution. So based on these two graphs, if our data is very close to our mean, it's going to be our graph on the left. It's a small standard deviation. But now if our data set has a larger spread, data points are spread out further away from the mean, then we'll say it has a large standard deviation, and it's going to look like our graph here on the right. So low standard deviation shows data points very close, and high standard shows over a large range of values. Now we have some properties of standard deviation. So the first one, standard deviation is only used to measure spread or dispersion around the mean. We're always focused on the mean. Standard deviation will never be negative. We're always going to have that spread. It's always going to be a positive value. Standard deviation is sensitive to outliers. If we have a data set that's 4, 5, 6, and then we have a 25 in there, that standard deviation will be affected by that 25, the outlier. And for data with approximately the same mean, the greater the spread, the greater the standard deviation. If all values of a data set are the same, then the standard deviation is 0, because each value is equal to the mean. Okay? A lot of these calculations, there are formulas that we can use. For IB specifically, they encourage using the calculator, and we're going to talk more in class about how to use the calculator to calculate the variance and the standard deviation. So a lot of these calculations you will not need to do by hand. You will be able to use your calculator, and again, we'll focus on that in class. So answer the couple questions at the end of this video. Come to class with any questions about the video, and we will get started on the classwork.